falls from a height of 500 meter above the ground, it falls with a decreasing force. This is what it says, because of the viscosity of the air, of course, until it reaches a maximum speed, that is the terminal speed. What's the work done by the gravitational force on the drop in the first and the second half of its journey? Density is given and work done by resistive force is asked if the velocity is 10 meter per second. So question is very lengthy, but there are small parts to it. See, total length, total distance that is covered by the body, that is 500 meter. Right? This is what the question said. Total height is 500 meter, 500 meters, right?
Yes, ma'am.
Now half of it will be 250, half of the distance. Now, see, it says we have to calculate what is the work done by the gravitational force. See, first of all, what is the terminal velocity? Basically, whenever you have any body which is moving, they're in a resistive medium, like viscous medium is there, air, not air, honey is there, glycerine, thick medium is present. So initially velocities are different, but at a point the velocities that are attained become the same. They do not change. That is known as the terminal velocity. So work done by the gravitational force is mgh. We know this, work done by the gravitational force is mgh. Problem lies with the mass. Mass is not given. Okay, h we know h will be 250 meter. G we know it will be 9.8 meter per second square, but mass is missing. But look, for the mass, the question said density is given. If we know density, we know the volume, we'll calculate the mass. For volume, it said take the radius as 2 millimeter. So 4 pi 3 pi r cube is the volume of a sphere into density. Density into volume will give you the mass. Density is 1000. This is the volume. So total is this much. 1000 into 4 by 3 pi r cube. Just convert r into millimeter. This is in meters. This is given in millimeters, but this has to be calculated in meters. Okay. So this is how we have the mass. Now work done in the first half will be mgh1, mass that is calculated into g into height. In the second half also it will be the same because height is the same, 250 meter. Leftover will be half is 250, leftover is 250. So this will be total, both the work done will be the same. Is this much clear?
Yes, ma'am.
Okay. Let's say this work done first half, second half is done. In the last, it says, what is the work done by the resistive force in entire journey if its speed is 10 meter per second? What is the work done by the resistive force? Total work done will be what? Total work done will be the sum of both the work done. You will add them. So total work done will be 2 into this means double of it. Basically, it will be double of it. Now, kinetic energy is half mv square. So half into mass into v square. That is the kinetic energy. So we know the total work done. We know the total kinetic energy. Now, right now we know work done is equal to the change in kinetic energy. Okay, so work done. Now, what is the work done? Question said that you don't just have a single work done. Total work done is there that you have calculated, but there is one additional work done by the resistive force. So total work done plus work done by the resistive force, this will make your entire work done. So this is equal to the kinetic energy change. Kinetic energy has been calculated because velocity was given to us as 10 meter per second. So kinetic energy could easily be calculated. And total work done, we've already calculated in the first part. Work done by resistive is missing. That can be calculated on subtracting these two. Got it?
Yes, ma'am.
Okay, so just note down the solution, Sana. Is there any other question?
Yes, ma'am.
Meanwhile, you can share it in the chat box also. Then you can copy this. Sana, where's the question you have not shared?
Ma'am, 1 minute. Ma'am, I have shared.
Wait, let me see. This is a question from error analysis. Error analysis is coming in your syllabus?
Yes, ma'am.
But that has been deleted from the CBSE.
But
Are you
my mom.
sure it will be coming?
Yes, ma'am. This is the question which came for PA1. I
Okay.
mean, unit test.
Okay, but that's very strange. Actually, this has been deleted. That's why we didn't even discuss it in the class. Anyways, I'll just tell you this. See, this says a radius of a sphere is measured. Error, the percentage error is given as 1.2%. Now, radius, the percentage error in radius means delta r by r is given as 1.2. Not in fact, delta r by r into 100 is given as 1.2%. This is what is given. Volume is what? Volume is 4 by 3 pi r cube. Now look, this is a constant term. This is a constant term. So just focus on volume and r. Volume will be delta V by V. We write it like this, the mean absolute value by the absolute value. And whatever is the power, it gets multiplied to delta R by R. Now what the question is, percentage or what? Percentage of error, no? Yeah. See, for percentage, what we'll do? We'll multiply both sides with 100. So delta V by V into 100 is equal to 3 times delta R by R into 100. Remember, whatever is the power in the formula, that will come and be multiplied. Now this term, we already know this will give us the percentage error in volume, which will be 3 into, this is 1.2 given. So that is 3.6%. Okay.
Okay, ma'am.
Any other doubts, Anna?
Yes, ma'am.
Please share the question first. You can take the screenshot of this. Sana, question?
Yeah, ma'am. 1 minute. Ma'am, I have shared.
Okay, this says a stone of mass 0.25 kg is tied to the end of the string. We have to find what's the maximum speed. See, first you need to convert. See, I'll tell you. Circumference of the circle will be, the complete circumference will be,
2 pi
so
r.
yes, 2 pi r, exactly, Sana. This will be 2 pi r. So 2 pi radius is 1.5. 1.5
Yes,
and
ma'am.
1.5
1.5.
will be 3 pi meter. Now speed is given in 40 revolutions per second per minute. So see, for the speed also, 40 revolutions per minute. You have to multiply it by pi by 30. Okay, for revolutions per minute, you have to multiply it by pi by 30. So this has to be multiplied by 3 pi by, no, this will be pi by 30 if you multiply 40 into pi by 3. This is revolutions given. Yeah, so into 2 pi revolutions, pi by 30, just multiply it with pi by 30. So this will be 4 pi by 3. Whatever will be the answer, this will be in meter per second. Okay, basically number of revolutions per minute into circumference by 60 seconds. I'll just write it in a better manner. Wait. To convert it, what we do is speed, to find the speed in meter per second, we take the number of revolutions per minute, multiply it to the circumference and multiply it, or in fact divide this by 60 because it's given in minute. So divide it by 60 seconds. Circumference by 60 seconds. So this will be equal to number of revolutions is given 40. Circumference is 3 by, so this is 60. 0, 0 gets cancelled. 3 to 2. 2 pi meter per second is the speed. Now, centripetal force, I think we have not discussed in the class. Centripetal force is mv square by r. So, mass is 0.25. V, it's 2 pi. That will be 4 pi square. By the radius is given as 1.5. You solve this, you will get the centripetal force. Now, this centripetal force will be providing the tension in the string. Whenever you have a centripetal force, Anna, the centripetal force acts along the radius and towards the center. So whichever force acts in this direction, that provides the centripetal force. Like in this case, the tension will provide. Tension will be acting across the string. So you equate them. Now question says, what do you have to find out at the end? What is the tension? So tension will be calculated using this. Tension will be equal to this 0.25 into 4 pi square by 1.5. Is this clear? This much of Newton.
Yes, ma'am.
It says what's the maximum speed with which the stone can be whirled around if the string can withstand a maximum tension. Now see, tension is given to you, speed has been asked. So same thing, mv square by r is equal to tension. Use this. This time the tension is given to you as 200 Newton. Mass is still 0.25. Radius is still 1.5. This velocity is missing, which you have to calculate. Like in the previous part, velocity was given, tension was asked. This basically you have to use this mv square by r is equal to tension. Got it?
Yes, ma'am.
Anything else?
One more question.
One more is there? Okay, share it. You can take the screenshots of this meanwhile so that you can refer.
Okay, ma'am. Ma'am, what is the general formula
What?
for tension?
Tension doesn't have any formula. Tension is a force that acts in the strings. So whatever force is balancing it, it will be equal to it simply. Tension will be mass into acceleration like a normal force. It's just a force. Okay.
Okay, ma'am.
Have you taken the screenshots?
Yes, ma'am.
Sana, we have discussed this question. Deflect the ball by 45-degree impulse. We did it in laws of motion. Same question we did. See, this is the rough surface. A ball has been, remember we did it like this. Impulse, you just have to calculate the change in momentum. And then the ball goes like this. This is given as 45-degree. If you recall, what we'll do, we'll resolve it. One component like this, one component like this. This will also become 45. So this will be V cos 45 degrees. This will be V sine 45 degrees. Similarly, this is also 45. So this way the forces will be resolved, velocity will be resolved because this is acting in a plane. And we need it either along x-axis or along y-axis. So this will also be 45-degree corresponding angles. This is a straight line actually. So this will become V cos 45-degree. This is V sine 45-degree. Without changing its speed. V is given as 54 kilometer per hour. You need to convert 54 kilometer per hour, just multiplied by 5 by 18. Just multiply this with 5 by 18. Okay, that will give you, this will be 4, so this will be 20 meter per second. Okay, this will be 20 meter per second. Now, see, you have the velocity. So initially, momentum across the x-axis, let's see. One is along the right side, other is along the left side. So choose a sign convention. Let's say this is positive, this is negative. So this side momentum will be mv cos 45-degree minus. What's the change? Change we calculate like this. Final minus initial. Initial will be minus of mv cos 45 degrees. So minus minus will become plus. So 2 mv cos 45 degrees. You can put the value. Now look at the y-axis, Anna. Both are in the downwards direction. So let's take down as positive because we don't need up. So look, this one will be mv sine 45-degree minus, this is also positive. So mv sine 45-degree. Both will cancel each other. Net momentum along y-axis will be 0. So this will be your final answer, 2 mv cos 45. Then you can put in the values for it. 2 into mass is given, what is the mass given? 0.15. 2 mv, velocity is 20. Cos 45 is 1 by root 2. This much will be your momentum. And impulse is actually change in momentum. So whatever is the momentum, that is the impulse. Got it? We have done this. Refer to the notes. Clear?
Okay, ma'am.
Have you understood?
Yes.
Okay then, Sana. So I'll stop then.
Okay, ma'am.
Do you want to ask anything else?